Hi, and welcome to this week's lesson on inequalities. We're going to have a look at representing inequalities on number lines, solving inequalities, set notation, combining inequalities, so when you have three different parts, and quadratic inequalities. So a lot of different topics in this. The only real thing we're not doing with inequalities this session is graphical inequalities, so shading regions. We'll be doing that next week after we recap straight line graphs. Okay, you will need a bit of prior knowledge for this, and you will need to be able to factorise a quadratic expression, both a simple one and one with a number at the front of it, so where a does not equal 1. So if you need to go and watch my factorising quadratic sessions beforehand, then do so. Okay, have a go at these questions. I'm just going to give you 1 minute or so to have a go, because they're nice quick ones this week, and then we'll get started. All right, off you go. Just a reminder that you can download all of these slides in advance from my website, mrsk'slightbulbmoments.wordpress.com. And if you have any questions in the session or after the session, just put a comment under the video and I'll get back to you as soon as possible. Right, should we stop there and go through it? I hope you've had enough time. These are nice simple ones to start with, just so we're all warming up and on the same page. So we've got two here to do with number lines. The first one, on the number line, show the inequality x is less than minus 2. So we're starting at minus 2. I'm going to draw an open circle because it's less than, not less than or equal to. And x is less than minus 2, so our arrow goes off in that direction. It doesn't need to cover the whole of the grid, it just needs to head in that direction. Okay, so open circle, arrow pointing left, starting at minus 2. Okay, our next one, write down the inequality shown on the number line. So we've got two parts here, which tells you our inequality is going to be in two parts. Let's first look at the left-hand bit. We have got x is less than or equal, because it's a shaded in dot, to minus 3, because that's where the dot starts. Okay, x is less than or equal to minus 3, or, because it could also be this top end, this one here is x is greater than, not equal to, because it's an open dot or a not filled in circle, and that is starting at 3. Okay, so that would be our final answer. X is less than or equal to minus 3, or x is greater than 3. You can't write and, because it is impossible for x to be less than or equal to minus 3 and greater than 3. Okay, it's not possible for it to be both of those, so we write it as or, this one or that one. Okay, let's look at these ones over here. On the number line, show the inequality x is greater than 4, or x is less than or equal to 1. So again, we've got two parts here. We've got an or. X is greater than 4. So start at 4. You think, is it going to be a closed circle, open circle? It's going to be open, and it's greater than 4, so it's going in that direction. The next one, x is less than or equal to 1. So it's starting at 1. This time it is a shaded circle because it's less than or equal, and it's less than, so it's going in that direction. Okay. Be careful where you're starting at, whether it's 1 or negative 1. It can be easy to sort of guess or assume and go against the question. Okay, so you've got two parts there for your two parts in the question. On our next one, you see this is one part. It's an inequality. It's got sort of three different aspects to it, but it's still one inequality. So that tells you you're really expecting one line or one section. Now it's between minus 4. Now, is that going to be open circle or closed circle? that one's going to be open because x is greater than minus 4, not equal to, and x is less than or equal to minus 1. So I'm also going to have a circle at minus 1, but this time it's going to be filled in, okay, because it's less than or equal. Now to show the area between them, you just join them up with a straight line. Okay, so that is my area. It's finite, okay, so it finishes at minus 4, or just before, because it can't actually be minus 4, and it finishes the other side at minus 1. Alright, super. Last one, list the integers that satisfy this inequality. So this one is slightly different, you might have to list them. It doesn't say set notation here, so just a list of numbers is fine, but we'll show you set notation later on because it might ask you to list the set. So look at the smallest possible number it could be. Now we've got a dot on minus 3. Could it actually be minus 3? Yes, because it's a filled in dot. Now it wants integers. Integers means whole numbers. Otherwise it would be an infinite number of options because you could have, minus 2.98 as one, for example. So we're going to go all the way up to our positive 4 there, and we're just going to think carefully when we get closer to that bit. So we can have all of these numbers. Now could we actually have positive 4? No, it's not a shaded in circle, so that means it is less than 4, not less than or equal. So that is your answer for listing the integers. Okay, to write that in set notation, you just use a curly bracket for listing a set, and you've got it. You've got your set of numbers. But again, I'll go through that in a bit more detail. All right, hope that was a good quick recap. We're going to recap some more of the real basic skills here, just so I know you've got them, but we're going to focus more on the complex side of things. So that's all the symbols, your greater than, less than, greater than or equal, less than or equal. And an example of stating the integers that satisfy, so using your whole numbers there. And then an example of what we've just talked about in the starter with the closed circles and the open circles and when you would use them. We've got set notation now. Now this is one of those things that a lot of people think is really confusing to start with because it doesn't look like anything you've done before, but it's just learning the pattern and how to write it out. It's not actually changing your answer at all. It's just writing it in a slightly different way. So first off, we use curly brackets for our set notation. Then the first x just means all the x values. So we're interested in x values. That's obviously if you've got the letter x in your inequality. If you've got the letter p, you would put a p there. Okay, just all your x values. The colon means such that, and then you get your actual inequality. X is greater than 0. Close brackets. So the set of all x values such that x is greater than 0. So I'll show you an example of what that would look like on a number line. We've got there our number line on the left, and on the right we've got the set of all x such that x is less than 1. So if we zoom in on this bit here, you've just got your normal inequality, how you'd write the answer like we were doing before there, and the rest doesn't change. Okay, it's just learning that format, that and a curly bracket at the end as well. Okay, the set of all x such that, and then you give your answer. Let's practice that skill a little bit. So here, underneath each blue square is either an inequality in set notation, or I've left out the number line and I've given you the inequality. So I'm going to give you 1 minute to see how many of those you can write out. Try not to look at the other answers in terms of set notation, see if you can memorise it, but check back if you need a hint. Right, off you go. "20 seconds. Choose one from the right hand column if you haven't yet. Okay, should we go through some answers? So under the first square, you should have got that. The set of all x such that x is greater than or equal to -1. Make sure you've got the equals bit if you need it. Be careful with that. The next one, our line should look like that. X is basically between -2 and 2. They've both got equal signs on as well. The next one is similar, but can you see they're not shaded circles? So we've got the set of all x such that x is greater than -1 and less than 3. So we'll say these ones as and, because it is both of those criteria. When you've got two separate options, two ends, you say or. So the next one, the set of all x such that x is greater than or equal to -5 but less than 10. That's that one there. We've got one closed circle, one open circle. And the next one is a two-parter. This is how we write it. So we actually write that little or in the set notation. So the set of all x such that x is less than -3 or x is greater than 3. It's giving you the two possible options for x. So the last one is just putting that in back into the drawing, and we get that. Similar but with your circles closed. Okay, I hope that's made sense. You're going to have a few questions later on in the session where the answers are asked for in set notation, so you will have to remember that little bit, and it's a good chance to practice it again. Okay, super. Let's have a little quick recap at some basic solving of inequalities then. I'm going to do the first two with you. I'm going to do question 1 and question 4. It's the first two from each column, and then leave you to do the rest. So just like an equation, but keep your inequality symbol exactly as it is. So I'm going to choose to add 2 to both sides first. So I end up with 6x is greater than or equal to 54. Then I'm going to divide by 6 and we get x is greater than or equal to 9. Okay, so exactly the same as your normal solving, but keep that inequality symbol. Don't ever write it as an x as an equals to do your working and then change it back. There's no point, and you'll forget to change it back. Keep it like that the whole way. The one thing you've got to note, because I don't really like just saying it's exactly like solving equations, is that if you change the signs on both sides, so for example you multiplied everything by -1, you would have to flip the sign. That's because you've basically switched the left hand side over to the right and the right hand side over to the left. But as long as you're careful about moving your negatives rather than multiplying by a negative, you should be fine. I'm just going to have a look at this one now. You can solve them with x's on both sides. You want to get rid of the lowest value of x, so that would also include the most negative. So even if I had like a -9x, I would choose to move that one rather than the 7x, because I want my answer to be positive. So I'm going to take away 5x from both sides. 2x minus 5 is greater than 9. Now I'm going to add 5 to both sides. 2x is greater than 14. And my answer would be x is greater than 7. Oops. Okay. So similar skill, similar practice. Can you have a go at 1 or 2 from either of the left hand side or the right hand side? Just giving you probably 40 seconds. Not long enough, but I reckon you can do 2 of those tricky questions in that time. Off you go. Halfway there, try your next question. Okay, and let's have some answers. X is less than 6 for question 2. X is less than 8 for question 3. Question 5, we got x was greater than or equal to 6. And question 6, x is greater than 9. Okay, I hope you got all your inequalities facing the right way, and remember the equal signs if they were there as well. I just wanted to highlight that point I was making about the difference between this and solving an equation, I'll just give you one example here. So if we had, for example, minus 2x equaled 10, then you could divide by minus 2 if it was a normal equation, and you would just get x equals minus 5. Okay, we could do that. You could have also done it as, got your interim step as minus x equals 5, so therefore x equals minus 5. You've just flipped the signs. You've got to be really careful when doing that with inequalities, because if we've got minus x is less than 5, that does not mean x is less than 5. Imagine if I added that x to the right hand side, so I've now got 5 plus x on the right hand side, then I took away the 5 from both sides. Can you see we've actually got, I'm going to write it with my x on the left, x is greater, because x is on the greater side, than minus 5. So when you get from this to this, can you see if you flipped the signs, so if they were negative and they've become positive, you also have to flip the inequality, because it's like you've just moved the x onto the other side, so therefore it's on the other side of the inequality. So it's just a little hint, remember, if you're changing all the signs of everything, flip the inequality sign as well. Okay, I hope that's helped. Right, let's have a look at these. I'm not going to give you time to do these now. These are slightly more complex solving, so building on what we've just done, rearranging them into equations and solving them that way. Pause it if you want to have a go. I'm going to show you answers now. Answers are up. Pause it if you want to mark your work. Okay, I hope you found those all right. Do leave a comment if you want me to go through any of them. Fab, well done. Okay, our next little topic then is combining inequalities. I quite like these, and they lead on to some quite tricky questions, but it's a really good skill there to make sure you really understand your inequalities. So 3 examples here, and then we'll take it up a notch. So firstly, write down the integers which satisfy both conditions. So if we just have a look at this question over here, you'd have to think what integers work in both situations. Now you might find it easier to draw yourself your own little number line for this. So if we have our numbers here, we've got x is between minus 5 and positive 5. So our top one would look a bit like this, all shaded in on that side and all open on that side. And then our second one would be x is less than minus 2. So let's say minus 2 is here. X would be that way. So which section would satisfy both of those? Can you see it's going to be this bit where they're overlapping? That is where the numbers are in both of those inequalities. So let's look at the bottom of it, minus 5. Could that be in both of those expressions? Yes, because of this all equals to, and it is still less than minus 2. So minus 5 works. Minus 4 works. Minus 3 works. Now what about minus 2? Minus 2 is definitely in our top bracket. Is minus 2 in our second? No, because it's an unshaded circle. So actually that is our final solution. Minus 5, minus 4 and minus 3. So you can either do them by drawing out a number line, or just having sort of, some people can just picture it in their heads there. You've got x is between minus 5 and 5, and x is also less than minus 2. So you've technically got this bit you're looking at. X is less than minus 2, but greater than or equal to minus 5. Okay, you've pulled out that part of the section. If you struggle with these, just draw a quick number line. I find it a lot easier to explain that way. So these ones already are on number lines, so let's have a little look here. Write down the integers which satisfy both conditions. So again, we've got this bit where they overlap, that's what I'm interested in. But think really carefully about the ones at each end. So 0 is where it starts. Could it actually be 0? Yes, because that's a shaded circle. Yes, it can be. It wants integers, so only whole numbers. The next whole number is 1. Again, that's right at the end of our section, but it is a shaded circle, so it can also be 1. Okay, so 0 and 1 are your only possible answers there. Okay, last one. So this one looks slightly more complicated. We've got a sort of and an or. We've got a two-parter and a one-parter. So we've got two bits of overlap. We've got either this bit down here to the left, which goes there, or we've got our bit up the top. Let's look at the left-hand side first. Now, what's the lowest possible value? If you look at that top inequality, that's going all the way left. It's just got an arrow pointing left, means it goes on to infinity. But the bottom one doesn't. The bottom one finishes at -5, but with an open circle. So it can't be -5. So the smallest integer would be -4. It could be -3. Now have a look at -2. That's on this other upper hand cutoff, but it is a closed circle, so it can include -2. Okay, so we've looked at those sections there. Now looking at the upper hand limit, our first number we get to is 1. It's a closed circle, so we can include 1. 2 is included, 3 is included. Next cutoff is 4. It's an open circle, so it's not included. So that is where our answer finishes. Okay, so drawing on those sections might help. Super. Should we take it up a notch and get a little bit trickier? Yes. Right, have a look at this first question with me. I'm going to go through one and then give you a very similar question for you to have a go at. So make sure you're paying attention. We've got a 3-part inequality here. You see we've got x is on the left, x is in the middle, x is on the right. So we've got algebra to solve throughout. Now some people would be tempted to try and solve this all in one go, doing the same thing to every part of the inequalities. In some cases you could, but it's quite rare. The best way to solve most of these questions is split them up. So we're just going to look at the left-hand 2 parts. So I'm going to rewrite those out. 4x plus 10 is less than or equal to 6x plus 2. Because I've just got my left-hand 2 parts. Now solve these. I'm going to take away 4x, so I'm left with 10 is less than or equal to 2x plus 2. I'm going to take away 2. And I'm going to divide by 2. Okay, and we've got x is greater than or equal to 4. You could flip that round and write it as x is greater than or equal to 4. I'm going to leave it like that for now. Now let's have a look at the other 2 sections. So again, I'm using that middle bit twice. I'm going to rewrite it, but with the right-hand inequality. So 6x plus 2 is less than or equal to 3x plus 26. Take away 3x, we've got 3x plus 2 is less than 26. Take away 2 and divide by 8. Divide by 3, sorry, to get 8. So we've got 2 solutions there. On the left hand, x is greater than or equal to 4. On the right hand, x is less than or equal to 8. So because they were part of one question, we've got to put them back together. And it means that x is less than or equal to 8, but greater than or equal to 4. We can literally just recombine them into one inequality. Are we happy with how that works? So you've just used the left-hand bit to sort of find the lower bound, the lower limit of that, and then the right-hand part to find the upper limit. Super. The next part is relatively straightforward. It says write down the set of all possible solutions where x is an integer. Interesting parts here, the word set suggests set notation and integer, so we need a whole number. So because it's set notation, we use our curly brackets, and then we just list all the possible integers. Now because they're both equal signs, it means we could include 4, 5, 6, 7, and the upper limit of 8. Close your curly brackets, and that's your answer. Okay, I'll leave that on the screen for you to have your go. So your question has just come up. I'm going to give you just over a minute on that one. All right, remember to split it up first, then put it back together. Off you go. Okay, are we finishing up? Right, solutions coming up on the screen, so check your work. That was your first equation, second equation, and all put together. Again, you can see I flipped that around to write it as x is greater than or equal to -1, but we could have left it in the other orientation to help us move it together. Doesn't matter which. And my set of all possible solutions goes from -1 all the way up to 5 again. Alright, I hope you're happy there with combining inequalities. Well done. Now we're going to move on to the last bit, and this is sometimes the trickiest bit. I would say before we start, always sketch a diagram. I always teach it and say the method is to sketch a diagram, and then students think they can do it without and storm through it and don't sketch and they get it wrong. So I really, really would say if you want to do well and be sure you're not making a mistake, sketch the diagram every single time. I do it when I'm doing any of my work solutions, when I'm just doing a rough bit of sketching to work out the answer to put on a slide. I will always sketch the quadratic. That's my #1 tip. Okay, I'm going to go through 2 examples with you and then give you some practice questions. So here, it's just like our previous inequalities, but here we've got a quadratic. We've got an x squared. Now our very first step is going to be factorise. We should think that straight away whenever we see any quadratic. So we get x plus 8 and x minus 3 is greater than or equal to 0. So you're just tackling that left-hand side like you would normally with a quadratic, but keeping the inequality symbol. Next, we're going to sketch for f of x equals 0. So that's just imagining my function, so my x squared plus 5x minus 24 equals 0, not the inequality. So my sketch, and this is where you might need to go back to one of our quadratic sessions if you've forgotten your graphs, would have roots at -8 and +3. Okay, we flip the signs in the brackets. So that would be my curve for equaling 0, but I want the bit where it's greater than or equal to 0. Okay, so I want this inequality to be true. So I want my function, so the curve, to be greater than or equal to 0. That's where the y value is greater than or equal to 0. Okay, because I sort of way to remember it is f of x is greater than or equal to 0. F of x you sometimes replace with y, because I could have written my top equation as y equals x squared plus 5x minus 24. Or you might have seen it as f of x equals x squared plus 5x minus 24. Basically just means the function, and normally it's the y value, that's the output. So we want the bit where it's greater than or equal to 0, so that means it is above the x-axis. Now, we've got to try and write those as inequalities now. Can you see we've got 2 parts shaded there? So in red, I've got the left-hand bit and the right-hand bit shaded. Let's focus on the left bit. My curve goes above 0 when my x values are less than -8. So my inequality looks like this. Now it's less than or equal to because of the question. Look back at the question and look, we had that or equal to. So that's what gives it there. That's because in the question it said it could be greater than or equal to 0. So greater than or equal to the x-axis. Okay, so that's my left-hand bit. And I'm going to write or, because we've got our 2 parts. For the right-hand bit, it's also above 0 when x is greater than or equal to 3. Okay, so that would be my final answer. I'll just go through those steps once more so you can see what I've done. We factorise like a normal quadratic. We sketch it as if it equaled 0. So just identify your roots, that's all you need. Then identify which part of your curve is needed. So if it says it's greater than 0, we're looking at the bit above the x-axis. If it says less than 0, the bit below the x-axis. Then write your answer as either 1 or 2 inequalities dependent on the number of sections you have shaded. So here I had 2 parts shaded, I'm going to have 2 inequalities in my answer. Right, should we try one more example? This one here is a slightly more challenging quadratic. You see we've got numbers all over the place, looks slightly different. So we're going to add a step at the beginning, and that's rearrange to the form ax squared plus bx plus c. So all you're doing is expanding that bracket and then subtracting the 17x from both sides. So you get 6x squared minus 17x plus 12 is less than 0. That's a common practice from your quadratics anyway, but here it's just we still want that 0 on the right hand side. Then it follows the same tact. We factorise. Now I'm not going to go through that factorising, go back to my previous video if you need a recap, but we get 3x minus 4 and 2x minus 3 in our brackets. Then we need to sketch, imagining that it equals 0. So our roots would be 1 at 4 over 3 and 1 at positive 3 over 2. So this time both positive roots. Now we want to shade the bit that's needed. So we want the bit where f of x is less than 0. Okay, see in this one we want less than 0. So that, looking at my curve, is going to be this bit down here. The bit where my curve is less than 0. Now can you see I've shaded one area, one bit. So therefore I'm going to have one inequality. So it's going to have x in the middle. X is going to be less than 3 over 2. And x is going to be greater than 4 over 3. It's not greater than or equal to, or less than or equal to, because of that question. Remember, that means it couldn't actually be on the x-axis. It had to be less than 0. So that's your final answer. One inequality for one shaded part. Just show you there. Okay, can we see how that works? Now the sketch is so important. I did drum into it at the beginning, but please do a quick sketch. It really doesn't take very long. You're just finding those roots and working out. It's important for if you're doing negatives. So if you've got a negative x squared, remember it's going to look more like a frown, an upside down shape, which will throw you off slightly. Okay, practice then. I'm not giving you a chance to do all of these questions, but I would like you to do some while my explanation is fresh in your mind. Set 1 are doing them exactly like I've suggested. You may need to rearrange first. You may have some negatives in this, be careful. Set 2 is exactly the same, but you have to give your answer in set notation. So if you want to test both skills at once, maybe just skip straight on to question 2. Okay, I'm giving you just over a minute there to choose maybe 1 or 2 questions, and then I would recommend pausing me and trying the rest in your own time. All right, off you go. Okay, keep going, choose another question. Right, and finish up the question you're doing. Okay, brilliant. I'm going to put some answers up now, so do pause it if you want some more time. The answers are coming up. Okay, these are your answers for part 1 and part 2. Hopefully you can find the question you've done. How did you get on? Let me know if you've got any concerns, put them in the comments box and I'll try and explain it. But I hope you managed those okay. Alright, pause if you're still marking, because I'm going to move off this slide now. Alright, well done on those. This one again, I'm going to leave it up for you to do as an extension, and I would suggest pausing this to have a go. It's the same skills, but there might be a little more rearranging first that you need to do. and look out for words like set. Find the solution set, which means write it in set notation. Okay, pause now if you want to do those because answers are coming up. And there are your answers. Pause to mark. Okay, super, really well done today. I know we did a lot of topics to do with inequalities and kind of whistled through them. Please spend a bit of time practicing those in your own time. If you've done all my questions and you still want practice, go on to Corbett Maths. It's got 176 to 179 on basic inequalities, and then 378 and 379 are on quadratic inequalities and set notation. All right, now see the little pink note at the bottom there? I'm only doing this for next week, so next week will be our last week for this. So you've got one more lesson on Monday where we're focusing on straight line graphs, and then the last lesson will be on Wednesday where we focus on graphical inequalities, so sort of bringing it all together. It's been a fab session, but I just realistically can't continue it for any longer. If you have enjoyed the sessions and you've got on with my style of teaching, you might be interested in booking some private tuition. I've got a few slots left. All the details are on my website, so if you wanted 1 or 2 catch-up sessions over the summer or something a bit more regular, then we can sort that out. So head on over to mrskslightbulbmoments.wordpress.com if you or anyone you know needs any tuition. All right, fantastic. I'll see you next week. Bye.